Ladies and gentlemen, boys and girls, I am Alan Willison, and it's my privilege to welcome you to this meeting of the Hartford Astronomy Group. It's lovely to see familiar and new faces, both in the audience and on Zoom. The format of the evening is, after these opening remarks, Martin will give a talk on the night sky. We will then pass over to Jerry, who will give the main talk of the evening. Jerry will talk between 45 and 60 minutes, after which time there will be an opportunity for you to ask questions. Following the talk, there will be a few closing remarks and reminders about upcoming events. With the permission of the speaker, the talk is being recorded and will be posted on YouTube shortly with a link provided on the club website. For those of you at the university site, we are not expecting a practice of the fire alarm, so if it does go off, please leave the building safely by the exits on each side of the screens. Congregate in the car park where we will be able to check that everybody is there safely. Please make sure your mobile phones are switched off or set to silent mode. We aim to finish by 9:45 as we have to clear up and be out of the building by 10 o'clock. For those of you on Zoom, please keep your microphones on mute during the presentations. You can use the chat facility to ask questions. We can carry on after the main meeting and have a little chat amongst ourselves, and we aim to finish by 10 o'clock. I now pass you over to Martin.
Hi everybody, can you hear me okay? Okay, so I'm going to give a quick talk about James Webb. We talked about it last month, about they were aligning the mirrors. And I just thought I'd share with you this image from the NASA website, which was last week, I think, or within the last 7 days. And as you can see, the diffraction spikes are being used to focus the telescope. The amazing thing I found there, if you can see, I don't know if you can see on that picture there, you can actually see galaxies in the corner here. So I think the effects we're going to get from James Webb are going to be absolutely fantastic. But that's the first officially released image. So there's a little bit of update there about the alignment using the near-infrared camera, or NIRCam as it's called. As the star image showed, previous image showed you. But the observatory still has 4 other instruments that are required to be aligned perfectly, contain sharp images, distant objects. So we're looking probably, we're well into June, maybe July, before we start getting some fantastic images coming out of that. Work will begin with guiding instruments called the Fine Guidance Sensor, or FGS, and then extended to the other 3 instruments. So, update on March 17th and how they're getting on. So that will be the next talk. I'll bring an update on how they're doing with that. Maybe we even have some images to look at by then. So Webb engineers expect that this process called multi-instrument, multi-field alignment will take 6 weeks to complete. So hopefully by our June meeting, we might have some exciting stuff coming through. Webb should complete its commissioning period around June, 6 months after the launch on 25th of December. On an ambitious mission to observe the universe from deep space and gather data and objects ranging from exoplanets to galaxies. As I talked about last month, about looking further back towards the Big Bang. So night sky, we're starting to get a few clear nights now, so maybe we can all get out and do some observing. So for this month, we're looking at the Lyrids meteor shower. So I've just shown there, April 16th is to the 25th each year, and showing the radiant. That's the position where the meteorites appear from. Now, any of you aren't familiar with the night sky, Vega is one of the summer triangle stars. It's a bright blue star, and it's quite low at the moment in the sort of northeast sky. But if you come across from there, you'll hopefully look in that area and hopefully see some meteorites if we get some clear nights. So the peak is on the 22nd, so that if it's a clear night, that's probably the best night to go out. So I thought it would be interesting to talk about Vega, or Vega, how you pronounce it. It's an interesting star, also called Alpha Lyra. It's one of the bright stars in the sky, and it's one we use to find our constellations, especially in the summer months, because it forms a part of what we call the summer triangle, which is Vega, Altair, and Deneb. But we can't quite see those. They are coming up later on in the evening, but Deneb is in Cygnus, the Swan, Vega, Altair slightly off to the side. But if you pick those three stars out and make the triangle, that's what we call the summer triangle. We'll use that as a reference for any viewing we might do. So a little bit more information about Vega. It's the fifth brightest star in the night sky, with a visual magnitude of 0.03. It's also one of the sun's closer neighbours, only 25 light years away. Interesting spectral star. It's believed to be quite young, not long being formed, but there's still some speculation about that. Also interesting fact there is that because the Earth's motion over a period of time, actually over 14,000 years, we get a wobble at the pole, and Vega will actually become the pole star instead of Polaris in the future, but a long while in the future. And I'll just try and explain a little bit about that, why this occurs. So it's called precession of the equinoxes. It's a motion of the equinoxes along the elliptic or plane of the Earth's orbit caused by cyclic progression of the Earth's axis of rotation. It's affected by the gravity of the other planets, the Moon. First person to first recorded information was a Greek astronomer, Hippocrates. Noticed the position of stars had shifted in a systematic way in the early Babylonian measurements. This indicated that it was not the star that were moving, but rather the observing platform, which was Earth in this case. So a motion is called precession and consists of a cyclic wobbling in the orientation of Earth's axis, the rotation period of 25,772 years. So that the image there gives you roughly what's happening. So at the moment we're currently looking at Polaris, North Star, but then 14,000 years will be Vega. Moving on to the next one. The other thing we can be looking at the moment, the end of the month, in the early morning, we've got a precession of planets coming up. So we've got Jupiter, Venus, Mars, Saturn and the Moon in quite low. So if we've got a nice clear morning, that on the 25th, that would be worth going out and having a look at. So Neptune, I thought we'll just talk a little bit about Neptune, something I picked up off the internet the other day, seemed quite interesting. Neptune's atmosphere has unexpectedly fluctuated over the past 2 decades. The planet Neptune is the most distant of giant planets from the Sun. Despite this, Neptune's atmosphere is extremely dynamic, with meteorological phenomena evolving over a surprising range of timescales. Neptune's thick atmosphere is made mostly of hydrogen and helium, with just a little bit of methane. So with powerful zonal winds in the solar system, Neptune's highest clouds evolve so rapidly that the planet's appearance changed dramatically over the course of days. So a bit of information there about gathering the data from multiple observations over almost 2 decades, and then combining it, the international team of scientists revealed unexpected changes in the atmospheric temperature of Neptune. The study suggests that Neptune is cooler than previously thought. But interestingly, there we've got some images there in thermal, infrared, and normal visible light. The study used observational thermal infrared wavelengths beyond visible light spectrum, effectively sensing the heat emitted from the planet's atmosphere. After analysing the data, scientists determined a more complete picture of trends in Neptune's temperature than before. That's a Spitzer telescope taking the thermal images. Thought we might talk a little bit about SpaceX. So, Starship rocket SpaceX could unlock the solar system and beyond. First orbital test launch of the Starship, the scientists are fantasizing about the possibilities it would enable them to visit Neptune, and it will also be useful for planetary defense. So a little bit of information there. Roughly 400-foot tall rocket. Starship is intended to carry astronauts to the moon. Elon Musk, SpaceX CEO, has loftier ambitions. He wants to use it to colonize Mars. Musk has stated that Starship might carry a great number of scientific instruments on flights, far more than is now conceivable. At the heart of the concepts is the fact that Starship is supposed to be not only enormous but inexpensive to launch. So, well, I don't know, 2 million is a cheap launch, but I'm glad I'm not paying it. So there's another interesting picture there. Looks like a moon base established. So 400-foot tall rocket is intended to carry NASA astronauts to the moon and to colonize Mars. Much has already been written about the Starship's capabilities for human spaceflight. However, the rocket has potential to transform our understanding of our surrounding planets and moons. I won't go into too much more. It was an interesting update. Right, so quickly going to move on to images that our members have been taken. We haven't had fantastic skies, but Steve's managed to pull out some more interesting pictures. This is a fascinating image of galaxies in the Marco-Radian chain. And there you can see M82, M86, NGC 4477. The numbers, you can see the numbers there, so you can see those galaxies there. As we move into the summer months, the galaxies are coming around more into view, and the nebulas in the Milky Way slightly turning to the daytime side of the, so we can't observe them quite so easily. Although there are still some nebulas that we can look at, but that's a fantastic image, Steve. Thanks. Another one from Steve. It's a Needle galaxy, a John galaxy, so we're looking at it almost as we look at our Milky Way. It's 40 million light years away, the constellation of Comet Borealis. It's a massive galaxy containing 1 trillion stars. Another brilliant picture. Another one, Steve's doing the show at the moment. So this is a nice solar image of the sun, showing some of the activity at the moment. We're moving into an active time for the sun, and the sunspots are dark, as Steve's indicated there. Done a bit of information about the temperatures here, 3,800 degrees Kelvin. sunspots can be very large, up to 50,000 kilometres in diameter. So another one Steve's down here, which is quite interesting. So we've got the Owl Nebula here, which is planetary nebula, which is a planet, sorry, a star that is similar to our sun. It's reached the end of its life and it's shed off its material. But what Steve is pointing out is these cluster of galaxies here. So the Higgson 50 reportedly the faintest, most challenging of the Higgson catalog, a magnitude of 18 to 19 and 2 billion light years away. So Steve, from his back garden, he's taking pictures of something 2 billion light years away. Pretty impressive, I think. Well done, Steve. And Steve Waters, one of our members, has done a picture. You probably recognise the Pleiades there. It's a wide field view of the Pleiades associated with the nebulosity captured with a little, used little camera there. Steve has really improved massively with his photography, so well done, Steve. The last one on mine, I did show a similar image to this last time. The only thing I've changed with this is just reworked it a bit and put the stars back in that I've taken out. The reason I take the stars out is that if I want to work on the nebula itself, I don't blow the stars up. So the Rota Nebula is hydrogen alpha region located near one end of a giant molecular cloud in the monocrose region of the Milky Way galaxy. It's an open cluster NGC 244 informed closely associated with nebulosity. The stars of the cluster have been formed from the nebula's matter. That brings me to the end of my show, and I'm going to pass over to Jerry now.
Right. Good evening, everyone. So nice to see lots of you here, and also a very good evening to those of you on Zoom. Those who don't know me, I'm Jerry Stone. I'm a freelance space presenter, and I run Spaceflight UK. I'm a recognised space expert, and I can say that because that's how I'm described when I'm interviewed on TV and radio. And I have a space-related Blue Peter badge. That's from when I was interviewed by Zoe Salmon for Blue Peter when she asked me about how rockets work. So I promote astronomy and space exploration. Pre-COVID, I went to schools all across the UK presenting space workshops in which we found out how many planets we really have in the solar system, which I pointed out to the teachers is not the number that's in the national curriculum. We built and tested planetary landers, built and launched rockets, and generally the idea was to get pupils excited about the STEM subjects. I also went all over the UK and abroad giving presentations on astronomy and space exploration. I gave my first space talk when I was at school in 1969. So I've been doing this for more than 50 years now. And I've been giving a series of presentations at the British Interplanetary Society, marking, or rather celebrating, because they deserve that, the 50th anniversary of each one of the Apollo flights. So I started back in 2018, and I'll be giving the final presentation in the series in December this year, when I'll be looking at Apollo 17. But now we've reached the 50th anniversary of Apollo 16, the first flight to explore the highlands of the moon. This was the penultimate mission in the Apollo program, and there was no major new hardware or procedures to test on the lunar surface. But they presented opportunities for astronauts to clear up some of the uncertainties in understanding the moon's characteristics. So scientists particularly sought information from the moon's early history, which might be obtained from its ancient surface features, the lunar highlands. And it was thought that the region where Apollo 16 was going to land had volcanic origins, and finding rocks and surface soil from that area would be a great benefit. In fact, because the astronauts had spent so much time studying the lunar samples brought back by previous missions, learning about the instruments to be carried on the mission, and hearing what the principal investigators in charge of those instruments expected to learn, this training helped them realize when they were actually on the moon that the rocks there were not volcanic. They could recognize that as a result of their training. However, the geologists back in mission control initially didn't believe them. So much of the training was conducted with the crew wearing spacesuits, which John Young said was very important. The landing site was in the region of the Descartes crater. And here we can see, sorry. No. So the small yellow circle in the middle, that is the landing area. And to the north is North Ray crater, to the south, South Ray crater. So the Descartes crater itself at the bottom was named after the French philosopher René Descartes. And during Apollo 16's exploration of the moon, back on Earth, NASA geologist Farouk El-Baz, who would later have a Star Trek shuttlecraft named after him, wrote on a blackboard, "There is nothing so far removed from us to be beyond our reach or so hidden that we cannot discover it." A quote from René Descartes. The command module on Apollo 16 was named Orion because they wanted something connected with the stars. And Orion is one of the brightest constellations seen from Earth, one visible to the astronauts throughout their mission. And Charles Duke also stated, "It's a prominent constellation and easy to pronounce and transmit to mission control. Spacecraft names had to be clearly understood over the radio." And so that was the name for the lunar module. The name for the command module was chosen by the command module pilot, Ken Mattingly, and he chose Casper after Casper the Friendly Ghost. And the reason he gave was, "There are enough serious things in this flight, so I picked a non-serious name." So here's the crew. Over on this side, Ken Mattingly. In the middle, John Young, the commander, and at the far side, Charles Duke, the lunar module pilot, who did not actually fly the lunar module. This is a strange thing about NASA terminology. The commander actually piloted the lunar module. The lunar module pilot, as he's called, gave assistance, calling out readings from the controls and monitoring the values. So John Young was selected in NASA's second group of astronauts in 1962. He flew on Gemini 3, which was the first manned Gemini flight, and that shows how well he was respected by NASA to have a flight on the first mission of Gemini. And he became the first American not from the original 7 to fly in space. After that, he flew in Gemini 10 in 1966 with Michael Collins, who would later fly on Apollo 11. And he flew as command module pilot of Apollo 10. So with Apollo 16, he became the second American after Jim Lovell to fly in space 4 times. His lunar module pilot, as we said, was Charlie Duke. He was 36 years old at the time of Apollo 16, which made him the youngest of the 12 astronauts who walked on the moon during Apollo. Ken Mattingly had originally been assigned to the prime crew of Apollo 13, but was exposed to German measles through Charles Duke, who was also on the backup crew. Duke had caught it from one of his children, and Mattingly was not immune. And the flight surgeon was worried that he might actually develop measles during the mission. And so just 3 days before launch, he was taken off the flight and replaced by his backup, Jack Swigert. He never actually developed measles. But as he now effectively became the backup command module pilot, that made him the prime command module pilot 3 flights later, Apollo 16. This is their backup crew, Stuart Rooser and Ed Mitchell, who both flew on Apollo 14, and in the middle is Fred Hayes, who flew on Apollo 13. And this is the transfer van that took the backup crew out to the launch pad for the countdown demonstration test. And you know it's for the backup crew because their names are at the bottom of the flight flap there. Now here's 2 of the prime crew, Duke and Young, on the flight version of the lunar roving vehicle, the LRV. And you know it's the flight version because if you look carefully, you'll see it is not resting on its wheels, but it's actually supported off the ground. The reason for that is because this is only designed to be used in 1/6 gravity on the moon, where it would be able to support twice its own weight. A typical car on Earth can just about support half of its own weight. Now, in aircraft, and indeed in the lunar module, the senior person, whether it's the captain or commander, stands when looking forward on the left-hand side. That's tradition. The reason the commander is on the left-hand seat when looking forward of the lunar rover is because he's right-handed. And the lunar rover is controlled only by the controls which are on the center unit. So he reached out with his right hand to steer and control the vehicle. So theoretically, the lunar module pilot could also reach out with his left hand and control it, but that never happened. No lunar module pilot would ever make the mistake of asking if he could drive the lunar rover. And no commander would suggest he do that either. Here's John Young at the top of the ladder going into the command module simulator, which is a full-size mock-up of the command module, and through the windows are projected the views that they would see while in space. And the viewing sections were various shaped boxes fitted around the outside, making John Young refer to the simulator as the Great Train Wreck. Here they are doing geology testing out in the field, and they went to places that would hopefully look fairly similar to what they might find on the moon. And here they are driving not the rover, but the Grover. This was the geological survey training version of the lunar roving vehicle. They also, as I've mentioned, did a lot of training whilst wearing spacesuits. John Young said this was incredibly important. And they checked out all of the equipment they were taking with them. Now, imaging was very important during the Apollo flights. And Apollo 16 had a huge range of photographic equipment, including a 16mm movie camera, a 35mm stills camera, and 3 Hasselblad 70mm film cameras, plus lenses, including the long silver one, a 500mm telephoto lens. And I came across this document. This is the Apollo stowage locations file, which lists where every individual item was stored in the command module and the lunar module. Equipment, food packages, medical equipment, and so on. It runs for 175 pages. And here's a typical page with 10 items on it. 1,750 items stored inside the 2 spacecraft. So it's not surprising you need a reference. But even apart from that, the crew pretty much knew. If you just asked them, where is so-and-so, they'd be able to tell you where it was. So here's the rollout of the Saturn V from the vehicle assembly building off to the launch pad. And one change made on the Saturn V here was restoring 4 retro rockets to the first stage, which is up to about where the black and white markings are halfway up the rocket. Now, these have been removed from Apollo 15 to save weight, because Apollo 15 was the first flight to include a lunar rover. And because of the extra weight and other new equipment that they had on there, they tried to reduce the weight of the launching rocket. However, it meant that the first stage didn't slow down as much when it was released after its fuel had been used up. And there was some worry that at a future flight, it might actually impact the engines of the second stage. So those 4 retro rockets were reinstalled. This is a view from the roof of the vehicle assembly building. And I can tell you from personal experience, it is one heck of an experience being up there. I've also stood in the flame trench at Launch Pad 39A, which is why I claim to have literally visited Kennedy Space Center from top to bottom. So here we are at the launch pad, and this is the silver vehicle maintenance tower, which moves in so that technicians can access all different levels of the launch vehicle. However, a problem arose with a leak in the fuel system from the reaction control rockets on the service module. That's the cylindrical section that the conical command module is fixed to, and it controls its attitude in space. So as a result, the entire rocket was taken back to the vehicle assembly building. And then the Apollo spacecraft at the top of the rocket was removed and brought down to ground level for repairs to be made. Once that was done and it was taken back out for the second time to the launch pad, then just a few days before the launch, the commemorative plaque was installed. While the spacecraft was inside the cone, which went all around the lunar module. And this is Ken Crowe fixing the plaque to the ladder of the lunar module. So here's the crew suiting up before going out to the launch pad, and quite determined, as the sign shows at the back of the room, to have a nice day. And this is one of the flight directors. This is Gene Kranz, who was one of the foremost flight directors. He played an important part on Apollo 11 and again on Apollo 13. Now, I used this picture a few years ago when I created some Christmas cards that I sent out to friends, and I added this. At last, the truth about Apollo 13, with this on it. I suppose I really ought to have sent a copy to Gene to ask his permission, but yeah, he has a decent sense of humor. So on launch day, April the 16th, 1972, the launch almost didn't happen. We've already had one major problem with the control system. Technicians at the Marshall Space Flight Center, where the Saturn V had been designed, were working on a problem with an onboard gyroscope. And they finally only gave a go for launch less than 1 hour before liftoff.
Now referring entire cooling. Cooling area has been shared around cooling. 2 minutes 90 seconds and counting. 2 minutes 90 seconds and counting. At 2 minutes 115 seconds, the spacecraft batteries will be turned on for launch. These batteries will be an additional power source to the spacecraft, as well as be acting as a backup for the fuel cells. These third stage hydrogen tanks now are pressurized. Third stage tanks pressurized. Second stage tanks also pressurized. T minus 1 minute and counting. Now moving into the final minute of the count. We'll be standing by to switch over to internal power. Switch over taking place at this time, bringing on internal power. T minus 45 seconds and counting. Lines is announced by John Young. That will be the last time for the crew aboard the spacecraft. T minus 35 and counting. Continuing for around T minus 30. T minus 25, 24, 23, 22, 21, 20, 19, 18, 17, guidance release, 15, 14, 13, 12, 11, 10, 9. We have ignition sequence start.
The Saturn V is 365 feet tall, 36 stories, and produces more power, 3 times as much power as all of the electrical systems in the UK put together.
go up from 10,000 foot closer to the Apollo 16 now, we have a water main. But with the Apollo 6 coming up on greater maximum aerodynamic pressure on the vehicle. 22 seconds, 6 nautical miles down, you're looking good. The dynamic pressure area is 9.93 megawatts. It's the most severe happening the entire aircraft, and it's critical, of course. 41 seconds of the minority, and so the 16 roll play line nautical miles down the tube, you don't just manually moving out the other traces of the Earth's atmosphere. And we'll see. All right, 2 minutes, 3 seconds, the status check, ignition control, that flight director Gene Grant, and no rubber safety. See this, I think, this beautiful shot, this new cap, coming up on the engine shutdown, you're going to see the first stage, and then separate. I like that alternating. So, engine shutdown on time. They doubled the number of nuclear rockets for this station. There was 26 nautical miles down to nautical miles down right. 15. It's separated right around 300, like everybody had it. So, double committee. That's there it goes. Oh, spectacular. You even saw the bells of the 230.
So the second stage engines burn liquid oxygen and liquid hydrogen. And this is so such an efficient system that you cannot see any engine flame from the rocket engines. The first stage uses liquid oxygen as an oxidizer, but the main fuel was known as RP1, essentially rocket propellant number 1. And it was a form of kerosene, with the result that back in 1969, the joke was that America went to the moon on SO Blue, for those of you who remember that. So then the second stage separated, fell away, the third stage took over and put them into orbit around the moon, around the Earth. And they did about 1.5 orbits before TLI, translunar injection. The third stage engine was fired for a second time to send them off away from Earth. And in this picture, you can see most of the United States, and particularly Baja California on the coast there stands out. They experienced a number of minor glitches on the way to the moon, but they culminated with a problem which seriously delayed the landing and possibly might have resulted in the landing not taking place at all. So late on April the 20th, Young and Duke left Mattingly in the command module and entered the lunar module and prepared to descend from lunar orbit to the surface. Mattingly was supposed to fire the service module engine to put the craft into a circular orbit, but he hit a problem. He had readings showing uncontrolled oscillations in the main engine's backup control system. The main system was fine, but mission rules said that they had to be able to rely on the backup if it was needed. So Mattingly did not make the burn. Now, by this time, he'd separated quite some distance from the lunar module. So the first step was to have the two craft close in again so that they could dock if necessary. And here you can see the command and service modules just to the left-hand side of the Earth as it rises above the lunar horizon. So this time, the chances of being able to go ahead with the landing seemed to be fairly slim. Experts were consulted at the Marshall Space Flight Center, at MIT, where they built the computer system, at North American Aviation in Southern California, who built the command and service module, and at Aerojet General, also in California, who built the SPS, the Service Propulsion System, the main engine in the service module. And as a result of all the investigations and the simulations, which took 6 hours, during which the crew made 3 orbits of the moon, it was decided that they could go ahead for another try on orbit number 16. So here's lunar module Orion, about to separate again from the command module. And here's a view out of the one of the lunar module windows as they went down towards the surface of the moon. Now there, towards the upper part of the picture, you can see a small black dot, which is actually the shadow of the lunar module on the surface. And there it is as they're ready to touch down. The lines coming down from the footpads are probes to sense contact with the surface. And when that happens, a blue light comes up in the lunar module, and it is marked contact, and they will cut off the engine. And there they are on the surface. So this is a view out of the commander's window, a panorama of the surface. But the delay in landing meant that that first EVA was postponed until the following day to give the astronauts time to rest first. Otherwise, in total, if you add in the 7 hours for the EVA plus the time to prepare for it and all the activities afterwards, it would have meant a 35-hour day for them. So here's a view of the back of the lunar module, and the rear panel shows buckling, and on the black plume deflector, there's blistering of paint. So April 21st, they unpacked the lunar rover, which you can see there in front of the lunar module, and set up the American flag, and Duke stood nearby to salute it, and as you can see here. John Young was not quite so steady with that. He was more enthusiastic. And that's the picture that was taken. How it jumped up off the ground. And you do have to make sure that you have your wording correct. He has not jumped into the air because there is no air on the moon. So then they set up the ALSEP experiments. This is the Apollo Lunar Surface Experiment Package. And on Apollo 16, this consisted of the passive seismic experiment, an active seismic experiment, the lunar surface magnetometer, and the lunar heat flow experiment. This was all powered by a radioisotope thermal generator, in other words, a nuclear-powered energy source. In addition to all this, there was a solar wind collector, as initially set up on Apollo 11, a cosmic ray detector. There was also something unique to Apollo 16, a telescope designed to operate in the far ultraviolet, which was possible on the surface of the moon not possible on the surface of Earth. And of course, the lunar roving vehicle. So Charlie and Duke took this picture of the lunar module, which is about 90 meters away. And in the foreground, we see the passive seismic experiment, a seismometer. And this reports seismic data on man-made impacts. So it would record the impact of the Apollo 17 third stage. And their third stage impacted the moon and was picked up by the Apollo 15 seismometer, which was already there, and the ones that had been placed earlier than that. So they had been left on Apollo 12, 14, and 15. Now, NASA had intended to calibrate the seismometer by crashing the lunar module's ascent stage after Young and Duke had returned to the command module. This would be an object of a known mass and velocity impacting at a known location. However, they lost control of the ascent stage after it was jettisoned, and so the impact did not occur. If we zoom in on that, you can see that the footpads, indeed the lower half of the legs of the lunar module, cannot be seen because of the way the surface of the moon is definitely not flat, and you can only see the very top of the flag. So the active seismic experiment consisted of a mortar unit which fired grenades, 4 of them, set off remotely from Earth after the astronauts had left. So the data from the 4 firings indicated that underneath about 12 meters of regolith, that's the surface soil, there's about 70 meters of impact debris on top of the main base material. This is the ALSEP Central Station, which controlled all of the experiments. That's the SNAP-7 nuclear generator, which provided about 68 watts of electrical power to the instruments. This is the lunar surface magnetometer, designed to measure the strength of the moon's magnetic field, which is only a small fraction of that on Earth. They also had a portable magnetometer, which was carried on the lunar rover, and they took readings at various sites as they explored the area. So in between the 3 aerials, you can see another part of it there, which is actually the sun shape. That's before it was deployed, and afterwards it looked like that. And this shows in the background Stone Mountain. Sorry, I can't take any credit for that, I'm afraid. And in the foreground is the heat flow experiment. Now, the objective of this was to measure the steady state flow of heat from inside the moon up to the surface level. And this involved drilling 2 3-meter deep holes, that's quite a fair way down, and putting thermometers down those holes. And they'd measure how much heat was flowing from the lunar interior. This was the 3rd attempt to place a heat flow experiment. The first one flew on Apollo 13, so of course it never reached the surface. And on Apollo 15, problems with the drill meant the probes did not go deep enough. So you see at the bottom there's a cable running from the experiment towards where the astronaut is standing. And that would go to the central unit. However, having set that up, Duke drilled the first hole and placed the first probe. But unfortunately, John Young, who was unable to see the ground right in front of him, didn't realize that he had the cable trapped around the leg of his spacesuit. And as he moved away, he pulled the cable out of the control unit. And a lot of work was quickly done about how he might be able to repair it. It was not designed to be repaired in situ, but they worked out a way it might be possible to do it, but unfortunately that's going to take far too long and would severely impact a lot of their other work, and so it was abandoned. So here's a view showing the lunar rover, the flag, and the solar wind experiment. So this was simply a lightweight material which would be set up facing the sun, and it would trap particles sent out by the sun. Now, because it was basically, I suppose you could say a panel, but an area hanging from a pole, and it was developed in Switzerland, it was referred to by NASA as the Swiss flag. So the first one of these was set up on Apollo 11, so I often have fun asking people how many flags were placed on the moon by the Apollo 11 crew, and the answer is 2. This is the other one. And this is the cosmic ray detector set up on one of the legs of the lunar module, and this was brought back to Earth after the mission. And here is the first telescope on the moon, the ultraviolet telescope, set up in the shadow of the lunar module, out of direct sunlight. And this made the first astronomical observations taken from the surface of the moon to obtain data on hydrogen, sources of hydrogen in space without the masking effect of Earth's atmosphere. And this is a false color picture of Earth taken from the surface of the moon. So the day side reflects a lot of UV light from the sun. The night side showed bands of UV emissions from the aurora caused by charged particles. And very tempted to ask Steve what this is a picture of, but I think even he, unless he's seen the picture before, wouldn't even realize this is the large Magellanic cloud taken in ultraviolet light. So here's John bagging a sample from a small crater behind the rover. And you can easily tell it's John Young because of the red stripes on his spacesuit. So when the Apollo 11 astronauts were exploring the surface, Andy Aldrin, one of Buzz's sons, was watching on television and turned to his mother and asked, "How can you tell which one is Mr. Armstrong?" A very valid question. It took until Apollo 13 before they had sorted out stripes on the commander's spacesuit. But of course, they never reached the surface of the moon on Apollo 13. So here's the flag, the rover with John Young, lunar module, and you can just about make out the UV telescope in front of the lunar module. And here's an image taken by Duke while sitting on the lunar roving vehicle during their journey to station number 1. But if you note, there's footprints in front of the rover, so this wasn't taken whilst they were actually traveling, but while they had stopped and Young had got off to go closer to the edge of the crater that you can see there. So here is Plum Crater. And John has left the rover and is heading over because something that they've spotted there was a large rock which was called Big Mooley, named after Bill Moolberger, the Apollo 16 Fields Geology team leader. In an email message in 1997, Bill Moolberger said, "Big Mooley was a problem from the moment we saw it on TV. The crew had been told to pick nothing larger than their fist. The labs could analyze remarkably small pieces and get results. So when we spotted Big Mooley with the television camera, we saw what looked like a large rectangle flashing at us. We jumped to the conclusion that it was crystal. That made the rock an anorthosite, which according to our pre-mission interpretations should not be present at this landing site. So naturally, they were interested to see it." So it turned out to be the largest rock returned from the moon. It was 11.7 kilos, 26 pounds, 2 stones in weight. That is one big rock. There's another view of John Young at Station 1. In front of him, you can see the gnomon. Where there's nobody in a photo, the gnomon will give an idea of scale because there's no trees or anything else on the moon that you could look at and say, oh, right, so that must be about this kind of size. So the gnomon is a set size. And here's John getting in a position to break a sample of a partially buried boulder on the west rim of Plum Crater. So the stills were all taken by the crew using their 70mm Hasselblad cameras. So rather than 35mm cameras, remember them? This took slides which were twice as wide and about 3 times as tall as a 35mm frame. It gave much better quality. In fact, John Young flew on Gemini 10, as I mentioned before, and his pilot, because he was the commander as he was flying his second mission, his pilot with him was Mike Collins. And being the pilot, Collins was the one who did the EVA. So he wasn't walking anywhere, he was just floating out in space because they were in orbit around the Earth. And it was at some point during that he lost his Hasselblad camera. So they looked around inside the spacecraft after the EVA and couldn't find it anywhere. And so unfortunately, all the pictures that Collins had taken were lost. The Hasselblads were built by the Hasselblad company in Sweden. So when NASA announced the loss of the camera, Sweden announced the launch of the first Swedish satellite. Apparently NASA replied with a reward available if anyone should happen to find it. Meanwhile, the TV camera on the rover was controlled by Ed Fendel back in Mission Control on Earth. And he was able to rotate it around, point it up and down, and zoom in and down. And in these couple of frames here, you can see slight movement of the camera. So that means that the astronauts' activities could be followed by the team in Mission Control, the support teams, and of course the general public around the world. Things didn't always go as planned. This is Duke hammering in a core sample tube. And as you can see, he didn't get far before he hit some very hard rock. And then he drops the hammer.
That's all right. I do that all the time. Yeah, my phone away.
So the obvious question is, why wasn't a hammer on a lanyard attached to his suit? Because as you can see, getting down low enough to pick something off the surface is not easy. So he decided to go and get some tongs to pick it up. So there's another picture showing the nomon, which also, as you can see, has coloured areas on it. And that means that you can calibrate image colours and say, okay, so we know what shade of grey this is supposed to be because it's the same as this particular rectangle on the nomon. And there's boulders of all kinds of sizes. So here's a photo taken from within the shadow of the lunar module, and that's John Young off in the distance, starting a drive from the Allset site to the lunar module at the end of the first EVA. And this is a 16mm film frame of him giving the LRV a speed workout in what came to be known as the Grand Prix at the end of the EVA. It was a 100-yard run and then a 180-degree turn and 100 yards back and then repeated. So this is a stabilized version, and they reckon that during this run he managed to get up to about 17 miles an hour. The music has been added, I hardly need to mention.
When he hits the craters and starts bouncing, when he hits the rooster tail.
Yeah, so the rooster tails, look at the dust going out behind the lunar module. So on Earth, in an atmosphere, it would create clouds which would last a while. But on the moon, it just goes up and comes down again. So that shows that this is in a vacuum. And by timing the dust going up and down, you can show that this is in 1/6 gravity. In other words, this is on the moon. There is no way you can doubt that.
When you get the rooster tail, fantastic. Yeah, good. We know every time we got up the ground pretty well. Go on from there. Okay.
So someone produced this showing what they would like the Grand Prix to really look like. I said that there were rocks of various sizes. This one's called house rock because it's literally the size of a house. And to demonstrate that, here's the two astronauts to scale. There is Charles Duke taking the sample. And on his left wrist, you can see the cuff checklist. So this is a multi-page thing, and it would give all of the information for the whole EVA, showing what he's supposed to do. However, the people who put these checklists together would also include extra bits and pieces, such as cartoons. This one says, looks bad, feels good. Not quite sure where that was referred to. Meanwhile, during one of the EVAs, there were 3 of them, Houston relayed the news that development had been approved of the space shuttle. And in due course, John Young was made commander of the first shuttle flight. Here he is training for that with Bob Crippen. And when STS-1 was launched, Young became the first person to fly into space 5 times. And on STS-9, 2 years later, he became the first to fly 6 space missions. Here's a picture taken during the run from Station 13 to Station 10. Altogether, Young and Duke drove the lunar rover for 26.7 kilometers. That's nearly 17 miles, far more than they could have possibly explored on foot. The limit on any individual journey was that they couldn't go any further than the distance they would be able to walk back to the lunar module if the rover completely failed. They also collected 96 kilograms, so 211 pounds of lunar samples for returning to Earth. EVAs 1 and 2 lasted about 7.5 hours. EVA 3 was 5.5 hours. And being out for that amount of time, they needed some kind of nutrient to sustain them. So fixed to the inside of the ring of their helmets, they had tubes of orange juice. Now, the reason for orange juice rather than anything else was that on Apollo 15, the astronauts were determined to be lacking in potassium, and orange juice is high in potassium. However, Young complained that the juice gave him wind, although that isn't quite how he worded it. He also said he hadn't had that much juice in 20 years, and in another few days, in other words, when he was back on Earth, he wasn't going to have any beep more. Another problem in working on the moon was quite simply falling over. Well, falling over wasn't a problem. Getting back up was a problem. So he's drilling into the surface, leaning over the drill, and oops.
Okay. We see that one went all the way up. Not quite. Here it is. Moving about 5 inches. Okay.
So the problem there was the mass of the backpack on his back, which is making it difficult to get back up again. Before they left the moon, on the last EVA, Duke left a family portrait on the surface. Then they both climbed back into the lunar module, and the ascent stage, the upper half, fired its engine to take them back up to lunar orbit. And as they got closer, yeah, you can see a fair bit of damage at the back of it. So they docked with the command module and transferred bits of equipment, all the rock samples, the film cassettes, and so forth, into the command module and left the ascent stage to go free. They then carried on in lunar orbit for a while. The command module pilot, Ken Mattingly, had spent 126 hours, 64 revolutions of the moon. And during this time, he took photos, he operated equipment that was in the scientific instrument module of the service module. And this is known as the sim bay. And it included, as seen in this photo from Apollo 17, a panoramic camera. So this took pictures of the lunar surface that were 4.5 inches high and 45.5 inches long. So they look like this. This one shows in the middle, we zoom in on it, the landing site from Apollo 15. And before they left lunar orbit, they released a sub-satellite from the service module, similar to the one already deployed on Apollo 15. It was to measure the effect of the Earth's magnetosphere on the moon and investigate the solar wind and the lunar gravity field. Then they fired the service propulsion system, the main engine at the back there, to send them back towards Earth. And during the return to Earth, Mattingly performed a deep space EVA to retrieve the panoramic film cameras, film cassettes, and other films. Then finally, they went through the Earth's atmosphere, out came the parachutes. Well, during the Apollo 15 splashdown, one of the 3 parachutes failed to open, resulting in rather harder impact than normal. But Apollo was designed to be able to land safely like that. So this was thought to be due to the parachute lines being dissolved when excess fuel that was left over was jettisoned. So it was decided on Apollo 16 not to do that. However, when the command module was being checked after its return to the mainland, that excess fuel exploded, injuring a technician. They decided that was not good after all. So here's a helicopter coming in to, first of all, send down some para-rescue men who put the inflatable collar around the command module and also inflated the life rafts. And here's Young and Mattingly in one of the life rafts before being picked up by the helicopter and taken back to the USS Ticonderoga. The Apollo 16 command module, the only part of the Saturn V and Apollo spacecraft to properly return to Earth, half of 1% of the weight of the entire stack. It was put on display at the Huntsville Space and Rocket Center in Alabama, though when I last saw it, it didn't have this clear enclosure around it. Now, 50 years after the mission, it's been carefully cleaned in readiness for its golden anniversary.
Apollo 16 was an Apollo mission that flew to the moon in 1972. This year is going to be the 50th anniversary of that flight. And so, since this is where that capsule lives, obviously we want to move things dust. And keeping the dust off is more than just for the look. Dust is made up of things like silica dust, but it's also made up of things like skin cells and could be pollen or all sorts of things. And so those different materials, if they were to build up and just stay there, could cause a lot of problems down the road.
This is a piece of history that human beings should be able to enjoy millennia from now, not just in the next few decades or centuries, but it should be kept and preserved because it represents one of the greatest triumphs of the space program of the planet Earth.
So a patch has been created marking the spirit of Apollo 16 and indeed all of the other Apollo flights. Ken Mattingly went on to fly 2 missions on the space shuttle. Charlie Duke served as backup lunar module pilot for Apollo 17 before retiring from NASA. And as I mentioned earlier, John Young went on to make his 5th and 6th space flights on the space shuttle. Sadly, he passed away in January 2018 at the age of 87. In December 1972, Apollo 17 became the final mission to the moon so far. And this shows the landing sites of all of the Apollo flights. So I'll be covering Apollo 17, finishing off my series on the Apollo missions at the British Interplanetary Society on December the 14th. And many people have been amazed about how long it has taken us, more than 15 years, to return to the moon. But that's about to happen. Next month will be the first flight in the Artemis program, an unmanned flight of the Space Launch System carrying the new Orion spacecraft, which will go around the moon and come back. So Artemis will place, as the statement has been, the next man and the first woman on the moon. And no, I won't actually be flying on it, but I do have my boarding pass. Much of the material for this presentation has come from the Apollo Lunar Surface Journal, which is an absolutely fantastic resource. So much so that although it was originally developed privately, NASA has taken it and are hosting it on its own servers now. And also the Project Apollo archive. I've also used material from lots of documents, including the Apollo 16 press kit, and of course my own personal space library. If you'd like to add to your space library, well, I have to say I have some copies of books which I've written about space exploration, as well as others which I haven't written, but I have here available at reduced price. So I hope you learned something from this. I hope you've enjoyed it and found it interesting. Thank you very much indeed. Any questions anyone would like to ask? Yes, okay.
You could see they were getting really dirty as they were walking about.
Yeah.
What would it do with the spacesuits?
Okay, so for those on Zoom, the question was that you could see in the films how dirty the astronauts got. And so what happened to the spacesuit? Are you talking about during the mission or afterwards?
Yeah, afterwards.
Afterwards, okay, so they were cleaned up as much as possible. They were not dry cleaned, they were wiped down, but lunar dust really gets into the cloth. And in fact, on Apollo 17, when they lifted off and rejoined their command module pilot, he said that there was no way that they were going to come into his nice clean spacecraft in that kind of condition. So the two of them actually had to strip naked before going in and putting on some coveralls. Lunar dust is a problem, and because it can get into the joints of spacesuits, which will make it difficult. So if you have so the gloves have a joint, so do the boots, and the helmet. So the question, are you going to foul up those joints? And so what you really need, ideally, is a suit that doesn't have parts that separate. But you still got to be able to make it so that you can have free rotation of joints. The other problem is breathing it in, because you get tiny, tiny moon dust particles into your lungs, and that can cause a problem as well. So I've suggested, in fact, that so that they had brushes, so they could brush down the spacesuits. But I have suggested that when we go to Mars, that those missions might be sponsored by Dyson. Yes, Steve.
Yes, Jerry, Richard Shepherd has asked the question. He said that he assumes that re-entry weight must have been calculated for safe return. So was there a weight limit set on the amount of material returned to Earth?
Well, they knew roughly how much they were going to be bringing back. And in fact, part of the issue with Apollo 13 was on their return, they didn't have moon rock and soil samples. And they think that that contributed to making their trajectory slightly off on the return. But I mean, apart from correcting the trajectory while out in space, you can rotate the Apollo spacecraft during re-entry. And because it has an offset center of gravity, that can take it up or down if need be. There was one. No? Okay, yes.
Yeah, you mentioned or described lots of instruments on the moon. Could you say something about the kind of discoveries they made from those instruments and from the rocks?
We don't have another 3 hours. Quite simply, look up Apollo mission results, and you will find hundreds of websites that go into simple summaries through to very complex descriptions of that. And that's what I would recommend. This is, I mean, basically, this is part of what I do. I encourage people to go and explore for themselves and find out what the Apollo astronauts did. And not only them, but the experts back on Earth who looked at the samples and both as gross examination, but also cutting them up putting them under microscopes to see detail of the inside. But one major thing is that it's now believed that, in fact, it had been suspected for a long time, that the moon was originally part of the Earth. And the current main theory is that another item, which we now refer to as Theia, hit the Earth, something about the size of Mars, hit the Earth and broke off this big lump, which became the moon. Sorry about that. So part of that is because of the similarity in material between the Earth and the moon. But there are some people who now are expressing doubt about that and coming up with other theories. But that is the theory which is currently accepted by most people. Yeah. Right, yes.
Jerry, what was the power source for the lunar rover?
The rover was battery powered. So one battery for the 4 motors for each of the wheels.
Could they recharge them?
No. That they were designed to run for about 6 days, and they were only going to be on the surface for 3.
So what are we talking about? What, lithium type or no, it would have been metal hydride.
I can't remember. Quick Google lunar rover batteries. So one question was, would it be possible to have higher capacity batteries and remotely drive the rover from its from one position to the expected landing site of the next mission? And that way you would have a lot of extra weight capacity on the next mission because you wouldn't be carrying a rover. But it was decided that that was too much of a risk. If anything happens to it during the journey or as a result of a very long journey, because they were, as I said, Apollo 16, for example, only covered 17 miles in total. But if you're going 400 or 500 miles, then you stand more of a chance of something going wrong during that trip.
You need very powerful batteries.
Yeah. And there's no Tesla charging stations on the moon.
Yeah.
I mean, the obvious thing then would be, well, why not have a large solar panel on the back that would be used to charge up the batteries? I mean, it worked for Mark Watney in The Martian, but that's Hollywood. Yes.
In your career, what's the one thing that's amazed you personally?
Wow. That we've been to the moon. I mean, seriously. I was 14 years old in 1969, which I reckon was about the perfect age to be. I was old enough to understand what was going on. And in fact, that's why one day, one of the science masters came to me and said, look, we were all interested in the moon landing and you know more about it than anyone. Could you give us a talk? And that was how I came to give my first talk. Actually, when that happened, I thought, I suppose I could. I mean, I've never done this before. And so I went home that day and I got out my NASA 35mm slides. They sent me a set after each flight. And I sorted them out into an order that would tell the story. And I wrote the script. And 2 weeks later came the day, I loaded the slides into the projector. I was introduced and they turned off the lights and I couldn't see my notes in the dark because nobody had given me any training about giving a talk. And so I just put the paper down and I spoke for nearly an hour without any notes. And that's pretty much what I've done since. So yes, I understood what was going on, but young enough to understand this incredible achievement that mankind had been looking at going to the moon and dreaming of it for, well, actually for hundreds of years. But recently, we'd actually started going into space. It could happen. And in 1955, I think, the year I was born, Patrick Moore wrote a book, which I have at home. I did say at one point I was keeping it for blackmail purposes, because at the end of one chapter, it says, with regard to traveling into space, that if the first flight to the moon might take place sometime in the 21st century, it's not unreasonable to assume that the first flight to Mars might take place in the 22nd. And that was actually written 14 years before we actually landed on the moon. And the reason that came about, well, you have to blame the Russians, because they put the first man into space. They put the first artificial satellite into orbit around the Earth. And then they put the first man into space, Yuri Gagarin. And Americans were horrified. I mean, this came as a huge shock to them that Russia had this kind of capability. Many Americans regarded the Russians as technically backward, and they couldn't understand this. The reason behind it actually was due to the Russians' inferior technology, which may sound a bit odd. When the Russians were developing their atomic weapons, because their technology was not as good as Americans, their atomic bombs were huge, clunky things, which left them with a choice. Either they would develop huge rockets powerful enough to carry these things, or they would carry on working on them until they developed ones which would be smaller and lighter that could be carried on their existing rockets. They went for the first choice. They built the huge rockets, which meant that when it came to putting things into space, they had big, powerful rockets to use. So there we go. And as a result of that, President Kennedy decided America not only has to do something that would put them ahead of the Russians, but to be seen by the entire world as being ahead of the Russians. And the decision was made to put a man on the moon. Right, I think there was one more. In that case, thank you again. And it's been delightful to be here this evening. Thank you very much.
I would like to repeat Martin's thanks to the speaker for such a fascinating talk. Our next talk is on May the 11th, when we have Mike Dvoretsky coming along to talk about that great astronomer, William Herschel, who died 200 years ago. I'd like to give you advance notice of the AGM of the Hartford Astronomy Group, which is due to be held on May the 18th on Zoom. We would like to see as many of you as possible come along to this meeting, as we have a couple of our team stepping down. If you think this is something you would like to be able to contribute to, please have a word with either myself or any of the committee members. That brings me to the last item, which is to say thank you to all the committee members who have worked so hard to make tonight possible. Thank you everybody for coming along, and do have a safe journey home.